Hello, and welcome to another Algebra 1 lesson. This is lesson 8.1. Our objective, identify characteristics of quadratic functions. Identifying characteristics of quadratic functions. A quadratic function is a nonlinear function that can be written in the standard form, y equals ax squared plus bx plus c, where a is not equal to 0. The U-shaped graph of a quadratic function is called a parabola. In this lesson, you will graph quadratic functions where b and c equal 0. That will allow us to focus on the effects of the value of a. Characteristics of quadratic functions. The parent quadratic function is f of x equals x squared. The graphs of all other quadratic functions are transformations of the graph of the parent quadratic function. Think transformers, robots in disguise. The lowest point on a parabola that opens up, or the highest point on a parabola that opens down, is the vertex. The vertex of the graph of f of x equals x squared is 0, 0. The vertical line that divides the parabola into two symmetric parts is the axis of symmetry. So here we have the vertex. For this parabola, it's the lowest point. The axis of symmetry is the dashed line that cuts down the middle of the parabola. For the graph of f of x equals x squared, the axis of symmetry is the y-axis, or x equals 0. Also notice, when you read a graph, you want to go left to right. This part of the parabola, even though it has an arrow pointing up, right here, it is considered to be decreasing because we trace the graph from left to right. Once we pass the vertex, it is now increasing. Decreasing, increasing. They call them transformations because you take the original function and you do something to it, like multiply it by the value of a, to change it and transform it into a different graph. Consider the graph of the quadratic function. Using the graph, you can identify characteristics such as the vertex, axis of symmetry, and the behavior of the graph as shown. Trace the graph from left to right to determine if it is increasing or decreasing. So this part is decreasing on the left side of the vertex. On the right side of the vertex, it's increasing. We have our axis of symmetry, chops through the x-axis at -1, so the equation of that line is x equals -1. The vertex goes left 1 and down 2. That is the point -1, -2. Let's write out all that information. Vertex, -1, -2. Axis of symmetry is always aligned. You can't just say -1. You have to say x equals -1. The domain is what x values you need to create this graph. It's all real numbers. We can use this symbol, the R, with the extra line in it to show all real numbers. The range is all real numbers greater than or equal to -2 because the range goes from the range is the y values. It goes from this point higher, everything above this. So all of the y values it needs all of these y values. We don't need any y values down here, so it's y is greater than or equal to -2. When x is less than -1, the function is decreasing. And when we say the function, we're talking about what is the y values doing. When x is greater than -1, the function is increasing. So on the left side of the vertex, it was decreasing, and on the right side of the vertex, it was increasing. All right, let's try some more. Identify characteristics of the quadratic function and its graph. Find the vertex. Write down the coordinates of that vertex point. To get to the vertex, we had to go over 2 and down 3. So that's the point 2, negative 3. The axis of symmetry. Axis of symmetry always goes through the vertex point and cuts the parabola in half. This goes through the x-axis at 2, so that means it is x equals 2. It's the equation of that line. Notice it's x equals the x value of the vertex. The domain is all real numbers. So we do a capital R with the extra line. The range, what do the y values do? The y values go from here up. We need all of these y values from here up. And the parabola keeps going up, so we even need numbers above that. So that's all the numbers that, of y that are greater than or equal to what number? Negative 3. You can see this number is the y value of the vertex. And it is decreasing where x is less than the x value of the vertex. X is less than 2 because we are decreasing this way, going from left to right, and then we're increasing on this side of the vertex, so that is to the right of x equals 2, so that's x is greater than 2. Right, try the next one. Start with your vertex, write it down. Check your answers with mine. This parabola opened down, so now our range, y had to be less than or equal to the y value of the vertex, because it's going down. We now want all of these numbers less than or equal to 7. And then our graph went the opposite direction. If we still want to go left to right, so this is our increasing part of the graph. And then once we get to the right of the vertex, now is when it's coming back down, and this is our decreasing part of the graph. So it's decreasing where x is greater than negative 3 and increasing where x is less than negative 3. Again, focusing on the x value of the vertex. Graphing f of x equals a times x squared. When a is greater than 0, our parabola opens up. When a is between 0 and 1, and you're multiplying by a number like 1/2 or 1/3 or 3/4, the graph is a vertical shrink. When you multiply by a number less than 1, you make the number smaller. So this is considered a vertical shrink. When a is greater than 1, you get a vertical stretch. So if you multiply by a number like 3 times x squared is going to give you bigger numbers faster. So that's a vertical stretch. So it's going to stretch up. This green one is stretched up from the blue one. It is up further away from the x-axis. That is a vertical stretch. Graphing f of x equals ax squared when a is less than 0. When a is less than 0, that's a negative number. But when a is between 0 and -1, we get a vertical shrink. But the negative itself makes it flip upside down. That is a reflection in the x-axis, where it was up here and it flipped over. It flipped over the x-axis. That is a reflection in the x-axis. When a is less than -1, say -2, -3, then the graph is a vertical stretch with a reflection in the x-axis. So when a is positive, a is greater than 0, the parabola opens up. When a is negative, the parabola opens down. Graph g of x equals 2x squared. Compare the graph to the graph of f of x equals x squared. So what's changed from x squared to 2x squared? We now have a 2. So the a value is 2. It is positive, so it opens up. When it says compare the graph, that means state the transformation. The transformation is that we have a vertical stretch of 2. Describe other things. We have a vertex of 0, 0. We want to graph y equals 2x squared. Our vertex is still at the origin, 0, 0. But putting one x value in at a time, -2 squared is 4 times 2 is 8. Then do it again, 2 times something squared, and we're putting in the x value. -1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Now graph your points. -2, 8. -1, 2. 0, 0. +1, 2. Notice it's going to be a parabola and it is symmetrical. These are the same distance away from the axis of symmetry. This point was 1 unit away from that middle line, that axis of symmetry. This one's 2 points away, or 2 spaces away, 2 units away. So this one will be 2 units away. 2, 8 over 2 up 8. There it is. Now draw your curve. And there's your graph. State the transformation, vertical stretch of 2, and graph it. That's example 2. Example 3. We now have a couple of things going on. We have a negative. That makes it flip over. And we are multiplying by 1/3. When you multiply a number by 1/3, does the number get bigger or smaller? It gets smaller. So it's a vertical shrink of 1/3. The negative gives us a reflection over the x-axis. Our vertex is still at 0, 0. Fill in your table and make your graph. Because our fraction has a denominator of 3, I chose x values that were multiples of 3. I put in the -3 here. -3 squared is 9. When I multiply -1/3 times 9, I can simplify. 9 divided by 3 is 3, and then I get -1 times 3. Notice my fraction went away. So that first number there is a -3. Try it again with -1. -1 squared is 1. 1 times -1/3. My fraction didn't go away this time, but I only had to multiply it by 1, so that's not so bad. How about 0? 0 times anything is? Try the next one. Fill them in, make your graph. So here's our numbers, -3, -3. Remember, we go in the x direction first. Y is in the sky. The word sky ends with Y. So I always say Y is in the sky because Y goes up here. We go the x direction first, -3. 1, 2, 3. And then Y value is -3, graphing this point. So I go back 3 and down 3. Next one, -1, -1/3. So -1 and down just a little bit. 0, 0. 1, -1/3. So we're going forward 1 and then down just a little. Just estimate for those fractions. 3, -3. Forward 3, down 3. And then draw your curve. Now, as compared to a y = x², this has been flipped over the x-axis. That's our reflection. And then it was closer to the x-axis than the parent function. So that is a shrink. It's like it got squished. And there's our graph for y equals, or h of x equals, -1/3 times x². Example 4. The diagram at the left shows a cross-section of a satellite dish. Satellite dish is a parabola, so it's a quadratic equation where x and y are measured in meters. Find the width and depth of the dish. So we want to know how far apart are these? Well, if this is -2, 1 and this is +2, 1, what is the width of the dish? Can't really count boxes here. This is 2 units this way because each 2 boxes is 1 unit. So to go from -2 to +2, that's 4. And it's measured in meters, so that's 4 meters. And then the depth of the dish. Let's see, what are we counting by? This was at 1, so that's 1 meter. That's all they asked for. Now, the equation of that was y = 1/4 x². So that is a vertical shrink by 1/4. And that's example 4. Compare the graph to the graph of f of x equals x². So when it says compare, that means state the transformation. There's 2 transformations we worked with so far. Vertical stretches or shrinks, and reflections over the x-axis. So this first one, what does that 5 do? We have a vertical stretch by, okay, here's our 3 choices. Vertical stretch by a number, vertical shrink by a number, or a reflection in the x-axis. So for number 3, multiplying by 5, does that stretch it or shrink it? It stretches it. So we get a vertical stretch by 5. And the next one, vertical stretch or shrink. Multiplying by 1/3, does that make your numbers bigger or smaller? Makes them smaller. So we have a vertical shrink by what number? 1/3. And the next one, multiplying by 1 or 3 halves. Does that make it bigger or smaller? All right, write down what you think the answers are to the rest of these. And pause your video. Write down your answers, and then unpause to check your answers. Remember, the ones with the negatives give you reflections in the x-axis. If you use the ebook on Big Ideas Math website, you have the monitoring progress problems have little play buttons next to them. And you can click on those and it'll play through those examples as well. All right, pause here to check your answers. Describe the differences between the graphs of negative 3x squared and 1/3 x squared. Well, this one has a negative, so how's that probably going to open? That one's going to go down, and it's going to have a stretch. This one, 1/3, that's going to open up, and it's going to have a shrink. So there's a couple different things going on. We have a shrink versus a stretch, and we have one that opens down versus opens up. It's important to know the differences and to know what our transformations are as compared to the parent function. All right, get started on your assignment 8.1. Thanks for watching. Have a great day.